So for those of you who I have not met, my name is Emily Schroyer. I'm a physical oceanographer at Oregon State University. I've been involved with the ASIRI project starting in 2013 and have spent a lot of time at sea through that effort. And then recently with Mesobob, I was on the 2018 pilot. I also wanted to be sure to thank Rama and ICTS staff and all of the organizers for this workshop and also discussion meeting. It's really been a great week. And I'm looking forward to the next 2 days. So my goals today are pretty simple, and they're also like a bit more just informative, especially for those who were not able to make the recent Seattle meeting. And so basically, I want to tell you a little bit about the pilot, and then I also want to introduce our next talk, which is a product of our workshop meeting that preceded this discussion meeting. So those are my two intentions. This is the science crew from last summer's cruise. It was Amit, myself, Drew Lucas in the room, as well as a collection of postdocs and students and technicians from both the US and India, a great group of people. So what did we do last summer? So here's the RV Thompson. This is actually an image taken from a drone camera out in the Bay of Bengal. The drone operator is sitting up here beneath the bridge with a couple of interested scientists watching him fly the drone. And then labeled on here, this is a picture from Gualtiero, Amala's student that's about to defend and graduate soon. But it's labeled here each one of our sensing platforms. So on the ocean side, the main platform we used was the FAST-CTD that I think Drew and Jen will talk about later. So getting upper ocean connectivity, temperature, and depth measurements. We also had a focus on the upper ocean, and we wanted to sample it cleanly. And so we spent some time getting clean measurements off the bow of connectivity, temperature, depth again, as well as adding some acoustics to get clean velocity data near the surface as much as possible. On the atmosphere side, we were launching radiosondes. We had microwave sounders, ceilometer, W-band radar, sea surface temperature measurements, and we also had the NOAA direct covariance flux system, and we're also had ancillary sensors to get good bulk formula estimates of the fluxes. So this is collectively our observations. I apologize if I didn't list something here, but they're pretty much all listed on the picture. So what did we do? The pilot leg I'm going to be talking about is leg one. There was a second leg that followed and deployed moorings throughout the bay. I will not be talking about that today. So on leg one, it was 4th through 23rd of June. We had to drive across the bay because we wanted to kind of be in a region that we identified as having some interesting precipitation signal before we left port. We had a collection of the ship measurements, which I just showed, but also a drifting buoy, which had air-sea flux sensors on it, as well as a subsurface profiler. You'll see that data in the next talk. And then we also had another drifting buoy set. So 5th, 6th June, we were doing kind of just logistical stuff and deploying those drifting assets. 6th through 18th of June, we were doing the primary ship-based observations. And the way we went about that is it's all kind of located in this one little subset here, but the ship would point into the wind, get clean atmospheric data, and then we would profile in the ocean. And we would slowly drift south just with the currents over the course of about 2.5 days. And then once we kind of judged we were too far from our other drifting assets, we would pick up the ship, recover, and then reset that drift and come back south again. And so there's a collection of 4 drifts here. And then you can see sort of these resources that are distributed here, the wire walker, which is one of those drifting profilers, the buoy, which also had ocean measurements underneath it, and then the ship data in blue. These were forming sort of a tight triangle, maybe at like 50-kilometer scales or so. And then within this little drifting short-term deployment, there's the larger scale observation system across the Bay of Bengal. And so we have the NIOT moorings represented here with the upside down gray triangles. We have the Rama moorings with the stars. On June 17th, we had a joint operation with the C-130, and as part of that, a couple of Alamo floats were deployed. And then we also had some gliders helping cover our southern edge of our domain. We're interested in a very large-scale phenomena, and so we tried to distribute all of these observational assets across international waters in the Bay of Bengal. And then finally, we returned to port June 21st, June 22nd, doing a longitudinal CTD survey with water sampling across the bay. So in terms of what the ship saw atmospherically, and we'll learn more about this in the next set of talks, here is the shortwave radiation. The clear sky value is in blue on the left-hand side, and then sea surface temperature is in red. And so you can see, especially at the start of the cruise, there were many days where we had very little incoming solar radiation, and that kind of changed towards the end of the cruise. At the same time, the wind stress here on the left ramped up and was pretty strong and steady at 0.4 newtons per meter squared. We were getting banged around. It was strong out there. And the direction was fairly steady, as would be expected in the southwest monsoon. And then we have the air temperature here with the cold pools, like Simon and Eric kind of pointed out from the piston data, and then the precipitation that followed. Here we're cutting off the scale. Some of these events go up much higher than this. I think this particular event reached 130 millimeters per hour. In terms of the phasing in the context of the BSISO signal, so this is the ship time projected onto the BSISO index by Kukachi. Sorry if I'm saying that wrong. But basically at the start of the cruise, we were in phase 6 of this particular oscillation index, and then by the end, we're in phase 8. If you want to know what that means in terms of the broad scale convective pattern, you can look at these lower panels. So this is phase 6. The blue represents enhanced convection, and the red suppressed convection. And so, at the start of the cruise in the Bay of Bengal, we were in this blue stage. And then at the end of the cruise, we have transitioned to a suppressed phase. Just again, another context picture. If you looked at the OLR at the start of the cruise, in the middle of the cruise, and at the end of the cruise, you can see some hints that we're seeing a change at the position of the ship. And what you're going to see in the next talk, so here's my next mission to you, is to introduce the next set of talks, is a product of our workshop that we had. About 25 participants came starting Monday, and they've been here from Monday through Thursday, both hearing lectures in the morning, but also working really hard on a set of research projects that I'll show you in the next slide. And basically, the overall goal of those 6 projects, they were all focused on investigating different aspects of the 2018 monsoon. And the hope was to put our pilot in a little more context in terms of both larger picture spatially as well as in time. And so, we wanted to use the workshop portion of this meeting to try to learn a little bit more, not only about the science, but about our specific, cruise effort from last year. And so the idea was, we'll have each one of these 6 groups working on some little piece of the problem, like the 6 blind men and an elephant. This is a cartoon that Eric brought into the concept. And hopefully, collectively, we'll put all of these pieces together and try to understand what the overall shape is. And so the 6 projects that we worked on, the first 2 were related to how the 2018 monsoon was described by large-scale products. So each of the groups was named after a harvest festival. We had Group Pongal addressing the question, how do reanalysis projects describe the 2018 monsoon? That was led by Leah and the group members that did all of the work. I'm just going to let you read their names. The second group, ONAM, looked at remote sensing and asked the same question. On the large scale, how did the 2018 monsoon look? And that was led by Niraj at SAC. He was an organizer of the meeting that we forgot to mention, Amit, so calling him out right now. The second set of questions was looking at the in-situ data. And so the first group, BIHU, looked at how does the basin scale array of moorings describe the monsoon and underlying ocean, so kind of thinking broader scale in the bay. And then the second group, HOLY, which is the group I worked with, was looking at the ship-based observations and the drifting buoys. So on a much smaller scale, just for the period of the ship, how did the 2018 monsoon look? And then the last set of projects, they were using simplified models and addressed the question, can the ocean response to the monsoon be explained by these models? The first group, Diwali, looked at how well a one-dimensional mixed layer model represented the observed evolution of the upper ocean. And then the second group was looking at a simple description of near inertial waves and asking the question how well those models do at representing the response of the upper ocean. So with that, I'm going to stop. And now, at the end of our discussion or workshop meeting yesterday, the groups were kind of presented with a daunting challenge of taking all 6 of these projects and forming one 15 to 20-minute talk that summarized the major results of their work. And so we're going to have 6 representatives from the 6 different groups come up and summarize what they found.